This is the function introductory video. In this video, what we're going to do is we're going to identify a function from a table, we're going to identify a function from a graph, and we're going to find the domain and range of a function. Now, before we get to the new material, let's do some review of what we talked about in the last module. In the last module, we discussed input-output tables. We had a rule that was an equation, and so we created this table by taking input values, replacing them with x, so we would do 2 times negative 2 plus 1, and then we get an output value. So we did input, output, input, output. We made graphs, we made tables, and so on. Now a function is just a special class of input-output relation. So let's look at some key terms before we get too far. First of all, we have this thing called a relation. A relation is when two sets of numbers are related to each other. Now, that could seem kind of obvious, but here I have an input-output table, and we could argue that any input-output table is a relation because I have an input and output. So we have these two sets are related to each other. So let's do a little bit of graphing real quick. So negative 2, 1. So on the graph, negative 2, 1 would be that point. 3, 5. So 3, 5. 0, negative 3. Negative 2, negative 2. And the point 7, 3. So these points on the graph represent a relation. They're just a set of points that are related to each other. Now a function is a special class of relation. It's very specific. So a function is a relation in which each input has only one output. This is a definition that you need to memorize. This is really, really important. Each input has only one output. So in this input-output table, each input has only one output. So when I plug in negative 2 for this function, I will always get 1. When I plug in 3, I will always get 5. 0, negative 3, when I always plug in 0. Negative 1, negative 2, and 7, 3. This table and this graph represent a function. Each input has only one output. Now when we're looking at a function, there are special names we like to use for functions to represent input and output. So for input and output, we say for a function that the inputs are called the domain of the function, and the outputs are called the range of the function. So for example, in the last table I had, my domain would be the points negative 2, or the numbers negative 2, 3, 0, negative 1, 7. Now notice when I'm listing the function, I'm giving these curly brackets on the beginning and end. We don't want to use parentheses when we're listing the domain and range, because then that could look like a point. A very odd point, but it could still be a point. So my domain are the input values, and my range are my output values. So 1, 5, negative 3, negative 2, and 3. Now when you're writing the domain and range, you don't have to write them in numeric order. Notice I just copied them directly from the table. If you wanted to, you could write it like this, negative 2, 1, 3, 5. But it really doesn't matter. Also, if there are ever repeats in your range, you don't need to write it more than once. We'll show you an example of that in a minute. Now you could be wondering, what's the difference between a function and a relation? Well, here's the difference. In a relation, an input can have two different output values. In a relation, a function can have two different output values. So for example, let's go back to our relation. So in our relation here, we noticed that here and here, I have two inputs going to two different outputs. Notice negative 2 goes to 1, and negative 2. This is what makes it a relation rather than a function. Now, in a function, each input has only one output. So notice -2 only goes to 1, 3 goes to 5, 0 to -3, -1 to -2, 7 to 3. So notice that it is a one-to-one relationship. In a function, an input x value cannot have two different y values. So what does that look like on a graph when an input has two outputs? Well, that's a great question. Let's take a look at this particular input-output table. Here I have x going to two different outputs. So we can say right now this is not a function. This is not a function because 3 goes to 1 and 3 goes to 5. So I'm getting two outputs for the same input. That's not allowed for a function. But let me go ahead and graph it just to see what it looks like. So when I graph 3, 1, 3 1's right there, and 3, 5, what do you notice about the 2 points? Well, if you notice, the 2 points are stacked on top of each other. Notice we see they're just right above each other. So let's make a little note of that. The points are directly above each other. So we notice that when one input goes to two outputs, that I have 2 points that are stacked on top of each other. Now, because of this fact, this gives us a very easy way to identify a function from a graph. And that's called the vertical line test. So to determine if a graph represents a function, you're going to drag a vertical pencil across the graph. If the graph crosses the pencil more than once, it is not a function. Now, more than likely, you have probably heard of the vertical line test before, but this example really helps us to see why it works. If I were to take a pencil and drag it across, at this spot, my pencil will go through 2 spots, will go through 2 points, making it not a function. So let's use the vertical line test to determine whether these are relations or they are functions. Let's start with the one on the left. So I see here that I have a circle, and so I'm just going to use this red line. I'm just going to say that's my pencil going through. There we go, pretty straight. So when I have my vertical line through here, you notice that I cross the graph 1, 2 times. So this is a relation. It is not a function because it fails the vertical line test. -1 has 2 different outputs. So this is a relation, not a function. Let's take a look at the one on the right. So here I have a line, and if I were to take a vertical line here, and we can kind of eyeball it, if I were to take this and scoot it across my graph, well, it would only cross at 1 point. So here I can't do it. So I see that there's nowhere that a vertical line would intersect the graph more than once. Therefore, this is a function. So what I want you to do is pause the video, and I want you to determine whether these 2 graphs represent a relation or a function. Be sure to use the vertical line test. Hopefully these 2 graphs weren't too difficult to determine if they're functions. Now we'll come back to the first one because I can clearly see that the graph on the right is not a function. If I were just to draw a vertical line here, I can see that it crosses more than once. So this is a relation because the x1 has 2 different outputs, here and here. So this is clearly not a function. Now looking at the one on the right, this looks like it's going to be the same as the line. So if I were to draw a vertical line, I see here that the x1 only has one output. And all the way along this graph, I see that there's only one output for each input. So this is a function. Now what we're going to do is we're going to look at a table, and we're going to determine whether it is a relation or a function. If it's a function, we're going to state the domain and the range. So what I'm looking for in my input-output table is I'm looking for any inputs that go to two different outputs. So let's see, I see 5 goes to 1, that's okay. Negative 11 has 1, 8 has 1, 4 has 1, and negative 7 have one output. So since each input has its own output, this is a function. No input goes to two different outputs. Since it's a function, I'm going to find the domain and range. So my domain, again, are the input values. So I'm simply going to write all my x's, negative 11, 8, 4, negative 7. And my range are simply my outputs, 1, 5, negative 3, negative 2, and 3. Let's try another. So let's see, I'm looking at my input-output table, and I'm looking to see, are there any inputs that go to two outputs? Well, looking at this, I see a 9 repeats itself in the inputs. Now that doesn't automatically mean it's not a function, because if this were a 1 and that were a 1, we'd be okay. But in this case, this is a relation. Let's talk about why. Because 9 has an output of 1 and 8. Since 9 goes to 1 and 9 goes to 8, this is not a function. And if I were to graph these on a coordinate plane, 9, 1 and 9, 8 would fail the vertical line test. So we can kind of look at it both ways. So here's what I want you to do. I want you to pause the video and determine whether the following table represents a relation or function. If it's a function, state the domain and the range. So now that we've looked at this table, let's see if it's a function. Now I notice that none of my inputs repeat. That's a great sign. And so each input has its own output. Now this was kind of a trick question. I was looking to see if you remembered the definition. This is a function. You could be thinking to yourself, all the outputs are the same. That's okay. We're allowed to have all the outputs the same. This just lets us have each input go to one output. So this is perfectly fine. Each input goes to one output, and it could all be the same output. So when I'm listing my domain, we're going to list all of our x's, negative 5, 3, negative 4, 2, 10. That's great. And then my output, I only need to put 1 because that is the only value in my range. So every number I plug in is going to give me an output of 1. So let's recap everything we have learned in this video. First of all, a function is a relation in which each input has only one output. Remember, that is the definition you need to know. Each input has only one output. The domain is the input of a function. Now, another way we could think of input is, remember, these are the x values. We know that the range is the output of the function. And again, these are the y values. And the vertical line test can be used to determine whether a graph represents a function.